Good morning, children. In today's video class, we are going to learn about neutralization reactions. This is from 10th class Physical Science, Acids, Bases and Salts lesson. So, already in the previous classes, previous years also you have learned what is neutralization. Okay. And in this class, what are the neutralization reactions and different types of neutralization reactions also we will be trying to learn. Okay. So, first of all, in the previous classes we have studied about acids and bases. So how can we identify the nature of the substance, whether it is as acid or base? How can we identify it? The simple thing is by testing the substance with the indicators. Okay, we have learned about indicators like phenolphthalein indicator, methyl orange indicator. These are some synthetic indicators we have studied. So by using the phenolphthalein indicator, we can identify. For example, if you take about 2 ml of dilute NaOH, take about 2 ml of dilute NaOH in a test tube and add 1 drop of phenolphthalein, a colorless indicator, to that NaOH solution. Okay, then observe the color of the NaOH solution within the test tube. After adding 1 drop of phenolphthalein indicator, immediately you can observe the pink color in the test tube. Okay, this NaOH solution, what we have taken, 5 ml of dilute NaOH solution, that will be turning into pink color when you add phenolphthalein indicator to that. So we can say that due to this color change, the solution which we have taken in the test tube will be the basic substance, basic solution. It is having basic nature. Sodium hydroxide is a basic solution, basic substance. Like that we can identify. Okay, to that same solution of sodium hydroxide, which is pink color, to that just you add about a few ml of dilute hydrochloric acid. Immediately you can observe that there is a loss of pink color. You can observe that the pink color, whatever pink color is gained by that solution, it immediately loses and the pink color disappears after the addition of dilute hydrochloric acid to the NaOH. What is going to happen there? Here, the basic nature of the sodium hydroxide solution will be nullified by the addition of hydrochloric acid. So that the solution is now converted from basic nature to the neutral nature or acidic in nature, depending upon the amount of dilute hydrochloric acid that you have added. Okay, if you add exactly equal amount of HCl, which is required to nullify the nature of the sodium hydroxide, then it will be neutralized and will get the neutral solution. Okay, if you add some extra amount of HCl, the solution becomes acidic. In both the cases, the pink color disappears. And to this solution, where there is no color, it's a colorless solution. And again, if you add 2 drops of NaOH to the solution acquires basic nature and again it shows the pink color. The pink color reappears. Okay, when you add HCl to this, again that becomes colorless. That means here why these color changes are taking place. This all depends upon the nature of the solution. Whenever the solution attains basic nature that you have taken in the test tube, it shows pink color. Whenever the solution attains neutral nature or acidic nature, then the pink color disappears and the solution becomes colorless. So by these color changes, we can understand the nature of the solution which we have taken in the test tube. Okay, these are a part of identification of the nature of the substances using that phenolphthalein indicator. And there are also remaining different types of indicators which we have studied in the earlier classes. Now we see neutralization reaction. For neutralization reaction, what we need to do is just to take about 5 ml of dilute NaOH. NaOH is a basic in nature. So take a NaOH solution and to that just we need to add a few ml of dilute hydrochloric acid to the solution. The basic nature, as we have discussed in the earlier, the basic nature of the NaOH will be completely nullified by the adding HCl, hydrochloric acid, and the resultant solution will become completely neutral in nature. The resultant solution is nothing but a mixture of salt and water. What we are going to get when a base is added to the acid or when acid is added to the base in a proper proportion, what we are going to get salt and water as the products. So the reaction of acid and base so as to get a salt and water as the products is known as neutralization reaction. This neutralization is taking place between acid and base. Hence it is acid-base neutralization. Okay, acid-base neutralization general representation is acid plus base gives rise to salt plus water. For that example equation I have written here. Acid means here HCl and base is NaOH. When dilute HCl is mixed with dilute NaOH, due to the neutralization reaction takes place, here we will get sodium chloride salt and water as the products. Salt is sodium chloride and water. Okay, like this. This is acid base neutralization, and another one is reaction of acid with metal oxide. This is also said to be a type of neutralization reaction, which is similar to the neutralization reaction. When acid reacts with metal oxide, also we will get salt and water. Why we are getting salt and water? Because these metal oxides are generally basic in nature. Metal oxides are generally basic in nature. Hence, this acid when reacts with a basic natured metal oxide, we are going to get salt and water. This is also similar to the neutralization reaction, and generalized reaction can be written as acid plus metal oxide gives rise to salt plus water. Acid, here we have taken is hydrochloric acid, HCl, metal oxide is CuO, copper oxide, and due to this reaction, the salt that we will get is cuprous chloride, cupric chloride and water. Okay. So HCl plus CuO, 2HCl plus CuO gives rise to CuCl2 plus H2O. This is also similar to the neutralization reaction. And another one is reaction of base with non-metal oxide. When base reacts with a non-metal oxide, also we'll get salt and water. So it is also similar to that of the neutralization reaction. Why? Here see, non-metal oxides are having acidic nature. See, non-metal oxides are generally acidic in nature. So non-metal oxides, due to their acidic nature, when they react with a base, they will get a salt and water. Due to the reaction between non-metal oxide and base, we get salt and water. Okay, non-metal oxides are example I have taken here CO2. So carbon is a non-metal, so its oxide will be the carbon dioxide, which is generally acidic in nature. So carbon dioxide, due to its acidic nature, when it is treated with lime water, that is basic solution, dilute basic solution, that is calcium hydroxide solution, we will get a salt and water. The salt formed is calcium carbonate, which is known as generally limestone and water. So this is also, as we are getting salt and water here, this is also similar to that of the neutralization reaction. These all three reactions are said to be the neutralization type of reactions, as we are getting salt and water at the end of the reaction. Okay children, this is about the neutralization reactions. We will meet in the another session with one more topic.